Hello, welcome. Let's try to solve another Leetcode problem. 1376 time needed to inform all employees. Let's first try to understand the problem. I think this problem is really difficult to understand because we are only giving a very simple example. But if you understand the problem, definitely this problem is going to become much easier. So this N means a company has N employees. So for example, this company has 1 employee and this company has 6 employees. And each employee with a unique ID is going to be starting from 0 to N-1. So this means the ID of each employee is going to be the index. So for example, it's going to be the index of the manager array, it's going to be the index of inform time array. So the index is going to be the ID of the employee. And now let's just try to understand the ID. So the head of the company is the one with the head ID. So the head ID equal to 0. So for the first example, this means 0 not going to be the head of the company. And for the second example, the head ID equal to 2. This means not 2 going to be the head of the company. Yeah. And now let's just try to understand what we are going to do. And each employee has 1 direct manager, giving the manager array where manager I is the direct manager of the ith employee. Yeah, let's first try to understand this one. We are giving this kind of a manager array. So this means this number 2 is a manager of index 0, and this 2 is the manager of the employee 1. And if it is a -1, this means it is the manager itself, so it is a 2. And if this is a 2, this means it is the manager of employee 3, etc. For 4 and 5, it's also the same. And now let's just try to understand what we are going to do. And it is also guaranteed that the subordinate relationships have a tree structure. So all the structure is going to be the tree structure. So the head of the company was to inform all the company employees of an urgent piece of news. So he will inform his direct subordinates, and they will inform their subordinates, and so on, until all employees know about the urgent news. Yeah, it's a lot of information, right? So the ith employee needs inform time I minutes to inform all its direct subordinates. Yeah, so this means, so for example here, so this means for the employee ID with 2, so he needs 1 time to inform all his subordinates. This means the employee 2 actually it is a manager. 1 he inform 0, 1, 3, 4, 5. So it's gonna need a time of 1. Yeah. So now let's try to solve the problem. Yeah. So basically we have a structure, tree structure like that. Let me just make it a little bit very simple. Not so many nodes. Like a binary tree, but basically it is not binary tree. Yeah. So from here, this is the head of the company, and this node will inform all its subordinates. Yeah. So for example, here maybe gonna be 1 and 1 because he needs 1 time to inform all his subordinates, and this node will have some time, maybe 2. He needs 2 times to inform his subordinates. Maybe here gonna be 3 times to inform his subordinates. So what gonna be the time when all employees know the information? So it is not 3, it is 4 because 1 plus 3 it is here. So 4 gonna be the time when all the employees knew about the information. So it seems that this is like calculating the longest path problem. It is not the shortest path because we are calculating the longest time. So the longest time is 1 plus this 3. So this means DFS is much easier to solve the problem. So from this node, we're gonna check its children. So what is the maximum value of the 2 children? So for the left children, it needs a time of 2 to inform all its subordinates, and for this node, it needs a time of 3 to inform all its subordinates. So the maximum of 2 and 3 is gonna be 3. Yeah. Now let's just check the parent. So for this node, it just needs 1 time to inform all his subordinates. So 3 plus 1 is gonna be the final result. So it's gonna be 4. Yeah, so this is exactly like a DFS idea to solve the problem. Yeah, so let's just try to use example 2 to solve the problem. So first of all, we're gonna build a graph. It's gonna be a default index. It's gonna be an adjacency list. Now we just enumerate all the nodes. So because the index is the node, so the index and value inside the enumerate of the manager array. Yeah. Now we can build the graph. So G with the parent node, it's gonna be this way. Gonna append it inside a list. It's gonna append I, because I gonna be the index. So we're gonna put it inside adjacency list. So this is gonna be the graph. So after we build the graph, we can start solve the problem by using DFS. So we're gonna start from this node X. Let me give a pause at this moment. So finally, we're gonna return the head ID. Yeah. First of all, we're gonna check its neighbors. But before that, let's just prepare a variable. It's gonna be the maximum informing time from his children. It's gonna be 0. So for y in gx, and we're gonna check the maximum time. Yeah. So it's gonna be the maximum of this value max with the DFS y. Yeah. So we've already got a maximum time. Yeah, because DFS y it's gonna be its children, and we're gonna check the maximum time for its children. And finally, we just need to return the maximum time from his children and from his parent. So the parent is going to be the inform time with this value x. Yeah. So this is going to be the solution for the problem. Let me just run it to check and submit it to check if it can pass all testing cases. As you can see, it passed all testing cases and it's pretty fast, and the time complexity is just e plus v. E is the number of edges, v is the number of vertices. So yeah, basically it is O(n), and n is the number of nodes, because this is just 1D array, and this 1D array just represents how many adds do we have. It is 10 to the power 5. So the time complexity is just O(n). Thank you for watching. See you next time.